Okay, am I audible? First of all,
Yes.
okay. Good afternoon. So today we will do some numerical problem regarding convolution. So we have some basic understanding with the little concept we have already on convolution. With that, we will further try to apply that concept in doing some numerical problem. So, but before that, let me share the screen. দেখতে পাচ্ছ?
Yes, sir.
Okay. Acha. So, in short, if we have to say, or briefly, or in a very simple way, we know that suppose we have any two arbitrary signal. One is the ft, and there is suppose the gt, and if we have to find a convolution between these two, and now you know that result as a result of this operation, we get a signal what is called the the convolve version of these two, which is suppose the ct, and so this is this is basically the convolve version of these two. So after that doing the convolution, the result you are getting is ct. So this convolution ct is basically, you can say in a very simple way, you can say that it is actually the the area under the product of the two functions. In one way, actually, that is true. So anyway, so let's take one example. Suppose okay, let's do one thing before going any intricate, before going any intricate part of the the numerical problem based on the graphical methods and so on. So let's try to do the problem almost by inspection. Okay, suppose you have to, what I'm trying to say is something like this. Suppose it is just based on your concept. You just apply your concept. You don't need to do any mathematics. You don't need to do any kind of take the help of any graphical methods, such step-by-step methods. You don't need. Just by looking at the relative natures of the two signals, uh, so we will try to predict, okay, how the nature of the convolved signal will vary. So suppose, for example, just based on our intuitive idea, suppose a very popular signal, that is e to the power minus t, e to the power minus t, that will vary from, say, this is 0 to t, and this is 1 at 0. This is suppose ft, and say gt, again another very powerful signal, very elementary signal, say unit step function. You just take, for example, let's say unit step function is 0 to t, and it goes like this. Okay, so just look one, just by looking at these two graphical two forms of the signals, actually, or the two kinds of signals, ft and gt. The one thing is very clear. In the last class, whatever example we did, mainly the signals were bounded in the sense, actually, that was one side bounded. Obviously these signals are also bounded within their range of operation. But the point is, what I'm trying to say is that one side, in this case, if you just carefully follow, that one side is bounded, or there is a limit, but other side is not bounded in that sense. That means in the extent I'm talking. So other side is basically, there is no limit. It basically tends to infinity. Okay, but in the last example, probably so far I can remember, we took the example of a get function, where the two sides are, there is bounded, and that means there were limits at the two sides, one for the left hand side, another for the right hand side. These kind of signals are basically at the left hand side, they're bounded. That means there is a limit, but at the right hand side there is no boundary. So basically it goes to plus infinity, like that. So, but again, with this nature of variation of the signal, obviously the concept of convolution will not change. We will apply the same concept over here, what we are already familiar with. So now the point is, you can just now what I mentioned, that I will not do any mathematics. I will not take the help of even the intermediate steps, the graphically what we do, the intermediate steps. I will not do anything. So just these two signals we have, and we will just carefully observe their nature, and just by based on our observation, okay, it's a bit kind of intuitive. So based on that, we will just apply the concept and try to find out what would be the nature of their convolved version. Okay, so we'll do it without doing any mathematics. Can anyone tell me what would be the nature of CT and why? At the back of your mind, you can run all those algorithms, okay, but you will not do it in the pen and paper. At the back of your mind, you can do it. That means that all the sub steps you can apply, like keeping one fixed and you are flipping, then sliding, and then overlapping area, something like that. All those things you can do it by your own, but that you will not write anywhere. It's kind of mental calculation. So the relative nature, that's why I told you that relative nature. I'm not interested in finding out. Bolo.
Sir, if I'm fixing f of t and I'm moving that g of t, that unit step function,
Okay.
So as long as the y-axis the y-axis of g of t is less than the y-axis of f of t, the
Y-axis.
I mean that that 0 to 1 part.
This part. Okay. This is 0 to 1. This is also 0 to 1. Fine. Okay, Nate, continue.
So as long as that part is to the left of ft, left of the y-axis of ft, the result will be just integration of e to the power of minus t from 0 to infinity.
Okay.
And
then
after that, if it moves to the right, the result will be, and suppose it is starting from t.
Okay.
So the integration then will be e to the power of minus t. The lower limit will be t to infinity.
Okay. Then what will be the shape of the resultant signal? I got your point. Whatever you were trying to convey. Okay, fine. But ultimately, then clubbing these two things, two parts together, what will be the ultimate shape or the resultant shape of the CT? Where from it will start, where it will end, or something like that, and how it will vary, so this kind of nature. Always remember one thing: this CT is basically actually the area under the product of the two functions in one sense that I just now I mentioned. It is basically the area under the curve, and the curve means the product. When the product, obviously, the product, finding out the product is possible only when there is overlap, only when there is a common portion. Then only the product is has some meaning, some sense. Otherwise, there is no sense of finding out product. Multiplied by the 0 will always give you 0. So in that, always remember this thing. This is basically the convolved version. Whatever signal we get, that is a convolved signal, or convolution, after convolution, whatever output we get, that is basically the product. This thing you should remember always. Then this kind of intuitive analysis will be easy. Okay, anyway, you just proceed. What will be the shape? Suppose with respect to t, again, any idea? বলো না, কোনো অসুবিধা নেই, মানে ভয় পাওয়ার কোনো কারণ নেই। তুমি অ্যাটেন্ড করছো, যেভাবে বলছো সেভাবে বলো।
স্যার শেপটা তো মানে মানে ইন্টিগ্রেট করে যেটা আসবে ওটা দিয়ে
কি রকম ইন্টিগ্রেট করে? তোমার কোনো, আমি তো তোমাকে কোনো ভ্যালু বলতে বলছি না, আমি তো তোমাকে রিলেটিভ নেচার ইন্টিগ্রেট করলে কিরাম আসবে, কিরাম আসা উচিত? আমি যার জন্য প্রথমেই বলেছি কিন্তু যে এটা রিলেটিভ নেচার। ওকে, প্রথমেই বলেছি। হ্যাঁ বলো।
সো ইন্টিগ্রেট করলে ই টু দি পাওয়ার মাইনাস টি, তো ইন্টিগ্রেট করলে 1 আসা উচিত মনে হয়।
মানে তাহলে কি মানে পুরোটাই ওয়ান থাকবে থ্রু আউট, এটা বলতে চাইছো?
না, থ্রু আউট
তাহলে
হবে না, মানে যতক্ষণ যতক্ষণ ওই জিটির ওয়াই অ্যাক্সিসটা লেফটে আছে ততক্ষণ, আর রাইটে ওটা ক্যালকুলেট করতে হবে।
আচ্ছা, আর কেউ কিছু? ঠিক আছে, তুমি একটু দেখো, আর কেউ কিছু তুমি যেটা বলতে চাইছো সেটাকে একটু সহজভাবে কিভাবে বলতে পারো সেটা দেখো। এনিওয়ান এলস?
স্যার সিটির সিগন্যালটা কি ওই এফটির মতোই দেখতে হবে, মানে আলটিমেটলি যে ফেজটা হবে?
এফটি তো একদম ডিকেইং এক্সপোনেনশিয়াল, বুঝতেই পারছো, স্টার্টিং ফ্রম জিরো। হ্যাঁ, একদিকে আমি তোমাকে যেটা বললাম যে বাউন্ডেড, বাট দ্যাটস দ্য লিমিট। সো স্টার্টিং ফ্রম জিরো আপ টু প্লাস ইনফিনিটি। সো এফটির মধ্যে ইফ সিটি লুকস লাইক এফটি, দ্যাট মিনস তুমি কি বলতে চাইছো এটাও ডিকেইং এক্সপোনেনশিয়াল?
হ্যাঁ সেরকমই স্যার।
লজিক, হোয়াট ইজ দ্য লজিক? তোমার বন্ধু যেমন একটা লজিক বললো যে ও যেভাবে ভেবেছে, তোমার ভাবনাটা শুনি। তুমি কোনটাকে ফিক্সড করছো, কোনটাকে ভ্যারি করাচ্ছ, আগে বলো।
না, ফিক্সড ভ্যালির ক্ষেত্রে আমি বলতে চাইছি মানে দুটোরই তো আসলে কনভলিউশন আসলে, আর কন্টিনিউয়াস টাইম এর ক্ষেত্রে
হ্যাঁ
তখন দুটো তো আসলে আলটিমেটলি মাল্টিপ্লিকেশন তো আর কি, মানে এরিয়া আন্ডার দ্য বোথ কার্ভ উইল বি।
হ্যাঁ, বুঝতে পেরেছি তুমি যেটা বলছো। হ্যাঁ বলো।
তো তার মানে যদি
মাল্টিপ্লিকেশন,
হ্যাঁ,
ঠিকই।
তার মানে প্রত্যেকটা টাইম মানে ওই সিটি কেবে যদি আমি মনে মনে ডিটি ভাবি, প্রত্যেকটা পয়েন্ট পয়েন্ট ওয়াইজ ভ্যারি করায়, তার মানে আলটিমেটলি কিছুই না, একটা মাল্টিপ্লিকেশন জাস্ট প্রত্যেকটা পয়েন্ট ওয়াইজ। তার
হ্যাঁ
মানে যেটা হবে, আর জিটিটাকে যদি দেখি ওটা একটা কনস্ট্যান্ট কার্ভ, তার মানে কনস্ট্যান্ট টাইম দ্যাট উইল বি সেম ইন নেচার অফ এফটি। ওটাই মনে হলো।
এতটাও ইজি নয় বাবা, আমি প্রথম থেকে বলে আসছি কনভলিউশন ইজ আ ভেরি কমপ্লিকেটেড অপারেশন। তুমি যে লজিকটা দিলে আমি বুঝতে পেরেছি, কিন্তু সেটা এতটা মানে 100% অ্যাপ্লিকেবল নয়। এটা কনস্ট্যান্ট আছে, ওটা ভ্যারি করছে, আলটিমেটলি তুমি তো মাল্টিপ্লাই করবে পয়েন্ট ওভার। অ্যাকচুয়ালি তোমরা আবার একটা বেসিক জায়গায় মানে মিস করে যাচ্ছ, মানে স্পেশালি তুমি। সেটা হচ্ছে তুমি যখন মাল্টিপ্লাই করছো, ইজ ইট এ মাল্টিপ্লিকেশন বিটুইন এফটি এন্ড জিটি? আমি কি বললাম? জাস্ট ব্যাক অফ ইউর মাইন্ড, ইউ জাস্ট রান দ্য অ্যালগোরিদম। তুমি যখন লাইক কম্পিউটার না, তুমি যখন কিবোর্ডে কিছু এন্ট্রি করলে, ধরো কোনো একটা প্রোগ্রামে ইনপুট দিলে, প্রোগ্রাম তোমার রয়েছে ডেটাবেসে স্টোর করা, ও জাস্ট এক্সিকিউট করে তোমাকে রেজাল্টটা দিল। দ্যাট ডাজন্ট মিন দ্যাট ইট ইজ নট ডুইং এনি এক্সিকিউশন। সো এক্সিকিউশন ইউ হ্যাভ টু ডু, and that is not with transfer, that is background at the back end, that is not at the front end. So which you as an user you cannot see. So just behave like that, like you are a computer, I am a user, I am just giving input, you will just give me output. It is something like that. So but it doesn't mean that at the background or the back end you will not run the algorithm. You have to run, otherwise the things will be completely erroneous, illogical things. So that means what? In the algorithm, I probably discussed with you the step-by-step methods. The first step, second step, what you have to do first, then second, then third, like that. So the sub-steps, if you can follow, the first step was you have to, keeping one fixed, you have to flip other. First step. That means you have to basically rotate around the vertical axis. About the vertical axis. You have to rotate it. You have to flip it. So when you flip, suppose keeping this, you want to flip it, or keeping fixed, you want to flip it. You have to flip it. So that whenever you are doing the multiplication, it is basically the multiplication between one function and a flipped version of the other. It is not a multiplication between ft and gt. It is a multiplication between gt and flipped version of ft. And it is, again, that is for one case, but for our rest of the cases, it is basically flipped. Flipping is always there. After flipping, you are doing the sliding. So flipped and the slided versions. So just after flipping, whatever multiplication you will do, that corresponds to n equals to 0 or t equals to 0. But if and just after flipping there is no common region, so the result will give you 0. That means in that case, suppose if this case, if it so happens, that means suppose CT will have a 0 value for t equals to 0. Like that. It's like that. So just to think, you just flip this, suppose, or anyone, you just think, you may flip this one also. So if you flip, and just at that point, whatever multiplication you will do, that will correspond to CT equals to C0 actually. So just to tell me, after flipping, whether are you getting any common region which you can integrate, multiply and then integrate? No. That will give you 0. So that means at t equals to 0, it is precisely equals to 0. Well, so after that, what do you do? What you will do? Obviously, there is no point just sliding the one function or the flipped version of the one function with respect to the other function in the left hand side. There is no point. Because when at t equals to 0, we are getting 0. That means there is no point shifting it to the left hand side. All will give you 0 value. So now we have to concentrate on the right hand side direction. What is going to happen there? So you just keep on sliding or shifting to the right hand side. Now we just see how the overlap portion is getting changed. Then you have to find that area under the curve and so on and all these stuffs. So in that case, what will happen? Can anyone tell me what maximum area you can expect in this operation? Maximum area, because ultimately you are multiplying between these two. Or maximum value rather. While you are flipping, suppose this function or this function, the height is not going to change. It remains always 1.
The maximum value will be 1.
Very good. The maximum value will be 1. Now you just see, ultimately you are drawing the limits, imposing the limits. Here you have imposed limit. Here you have now imposed limit. So limits are going to be imposed one by one. Now just think, you know from where to start and how it will change or behave or move. Now you tell me, what is the nature of its variation? That should be, rather. It should be. Suppose say আমাকে ড্র করতেই হলো, সাপোজ এই সিগন্যালটা আছে, ফ্লিপ করেছো, ঠিক আছে, f of minus t ধরো, এটা আমি আর লিখছি না, f of minus t. Now you just think this signal, এই সিগন্যাল এবার স্লাইড করছে, ওকে, এই হচ্ছে t axis along t axis. Now you just think in the second step what would happen? The signal will come somewhere here. In the third step, suppose here. Fourth step, I mean just arbitrarily কিছু step নিচ্ছি, intermediate steps like this. Fifth, এটা তো হচ্ছে এইভাবে তো যাচ্ছে এইদিকে along this direction.
Yes, sir.
How long this process will continue?
So for infinity.
For infinity, very good. For infinity. So there again, that means again at one side it is bounded, or limit, that is the limit, that means 0, and the other side it is infinity. And can you just from this analysis now, I've drawn a few steps, intermediate steps. So suppose 1, 2, 3, 4. So can you tell me how the area is changing? Area of the overlap portion is changing.
Sir, area is increasing.
Area is increasing. Very good. At least this point is clear. Area is increasing. Now, is it increasing linearly or non-linearly? What it should be?
It's a non-linear.
Non-linearly. Very good. Very good. So, join করছে। Okay, so it will basically change like this, na? When, suppose, let's take this case. When exponential comes here, it never touches this axis. So it at that time, what area will get? Almost equals to 1. So initially it will keep on rising very fast, very fast. Then the pace will slow. Then the pace will be slower, at slower pace. Then actually it will try to follow the, what will be the maximum value? 1. It cannot exceed 1. So 1, but it cannot touch because this point is asymptotic kind of. So here also this asymptotic nature will be reflected. So it's almost about to touch 1. I think at some point at infinity maybe may touch. So it is something like that. So initially its area, look at this first one. So area increasing, then again increasing, more, but the way it starts increasing in the initial phase or initial stages or for the lower values of t, that pace will be reduced, and gradually it starts to follow or starts to take the value which is equals to 1. But again, that may take at infinity. So this is the nature. And can you tell me what is the mathematical form of this graph? ম্যাথমেটিক্যাল ফর্মটা কি হয় এরকম ধরনের নেচার? আরসি নেটওয়ার্কে করেছো না?
So 1 minus e to the power minus t.
1 minus
e to the power minus t. এইবারে ম্যাথমেটিক্সটা করে দেখো এটাই পাচ্ছ কিনা। ঠিক আছে, এইটাই বল। আমি 1 minus e to the power minus t টা আমি চাইছিলাম না, আমি জাস্ট তোমাদের রিলেটিভ নেচারটা জানতে চাই। এনিওয়ে সেটা ঠিক আছে, বলছো যখন খুব ভালো। তো সেটাই হচ্ছে ব্যাপার, তোমাকে এইটা বুঝতে হবে এখান থেকে যে জাস্ট বাই ইনটিউশন, যে তোমাকে ভালো করে অবজার্ভ করে, জাস্ট কেয়ারফুলি অবজার্ভিং দ্য নেচার অফ দ্য টু ইন্ডিভিজুয়াল সিগন্যালস when they will be convolved, when or the convolution operation will be employed between them, how the resultant signal will look like. Intuitive idea টা থাকলে তুমি যখন ম্যাথমেটিক্সটা করবে, তোমার ultimately what the result will get, and you can just cross check with your thoughts, whatever you thoughts before doing it. You thought something that this kind of nature I can expect. So after doing the mathematics or the graphical method, whatever, so you just cross check. Okay, so whether my thinking is right or wrong. So the thinking process will be powerful. Again, just to take another example, if you understand this, then this is even simpler. So suppose, for example, you have again just take this thing ft, that exponential again 0 this is this one, this is 1 actually, this is 1. So e to the power minus t, and I'm going to convolve with আগেটা কি দিয়েছিলাম, ইউনিট স্টেপ দিয়েছিলাম তো, এটাই না gt. Now you do the convolution. What result do we expect? It is basically the flipped version of it, right? It's u minus t actually. So here it is my gt and this is my ft. So just twist it a bit, the previous problem. In this case, what would happen? You have to first flip one, either this or that. You can flip this, you can flip that, anyone. So do it and tell me what will be the resultant nature.
Sir, in this case, the area is also increasing like the last case.
Area is also increasing means, first of all, no, before that, just let me know that where from it should start, up to which extent it should go, what would be the means maximum limit in amplitude. These points will be clear first. Along t-axis, from which point it should start, and up to what extent it should go.
So from 0 to infinity, minus infinity.
0 to minus infinity. Okay, that means in this direction. Suppose if it is 0, in this direction. Why don't you think there will be any positive non-zero value for the
It will be
positive?
from minus infinity to plus infinity.
Very good. It will be from minus infinity to plus infinity. Very good. It will be from minus infinity to plus infinity. And what is the maximum value we can expect in amplitude?
So 1.
1. It can never exceed 1.
1.
1. Very good. So at least these 3 points are clear. That is minus infinity at this side, at that side plus infinity, and top 1. So along axis, 2 axes. So these points are clear. Now we are interested with the shape. Now just tell me.
So it will be opposite of
Sir,
the first one we did. Like from minus
Opposite-
infinity.
Yeah. So the graph will be decreasing. I mean, it will be, if we take the limit from minus infinity to plus infinity, the graph will be increasing in nature from minus infinity to plus infinity. So that will
Minus infinity
result
to
in
plus
an,
infinity increasing in nature.
that means from 0 to infinity, it will decrease the graph.
0 to plus infinity,
Yes,
it
sir.
will decrease. Okay, and what about from 0 to minus infinity or minus infinity to 0?
So it will be 1, means it will be touching 1, but it won't touch 1 like the previous one.
It will be touching 1 but not 1. Okay, that means the nature, how the nature should vary.
Sir, from 0 to minus infinity, it will be 0, I think.
But just now you people told that the limit is from minus infinity to plus infinity, non-zero. Which one is correct?
So from 0 axis, from the vertical axis, it will slowly start to decrease.
Yes, sir.
It will slowly start to decrease from
Yes,
0.
sir.
Okay,
Yes,
towards positive infinity.
Positive
Right, so?
infinity.
Okay.
So,
And what about from 0 to minus infinity?
sir, it will be acting like an unit step function, like
Very good. Very good. Very good. It will be acting like a unit step function. This. And here it will be just this thing. E to the power minus t will be the nature. It is just a unit step function from this point. Why? Just think it's like this. You just think this is the flipped version. G of minus t. Flipped, just after flipping, you just see. Just after flipping, are you, if you just multiply these two points, you just multiply these two, so you are getting some value. That value is 1. Okay, now if you suppose this signal, keeping this fixed, suppose you want to no, I have flipped this, so you have to slide this one, you have to slide this signal. So you are trying to slide this signal with respect to this in the left hand side. What is going to happen? What will happen? Always
Sir, the area remains constant.
the area
from
remains
whichever-
constant. Exactly.
And that will be
Area
equals
remains-
to 1.
area remains constant. Area, very good. The area remains constant. Exactly. Right language you used. Area remains constant. So that is why it is equals to 1 always. And what about in the right hand side? Suppose you are trying to slide it, okay, this thing in this direction with respect to this. As you are moving, gradually the area under these two getting reduced. And what is the nature of reduction? Or how it is getting reduced? in this
e to the
way.
power minus t.
Exactly, in this way. So that is why it is e to the power minus t. That's all. Okay, so this is another example. Now we can take another one. Again, we will not do any mathematics here also in this case. That is, suppose we have ft, this is 1, 0, and this function. Again, at one side it is a limit, but other side there is no limit. That is totally unbounded. And let's take another example. Another signal, gt is t, it is 0, and this is something like this. Okay, so you have to do the convolution. Now the point is, this signal, as you can understand, is basically shifted from 0 to the minus t. That means shifted to the left hand side. This is the same signal, but that is shifted to the right hand side by the same amount. This is also t, this is also t, but here it is a negative side, here it is at a positive side. But both the signals are basically same. At one side it is completely, and it means unit step function kind of. Okay, so actually it's a unit step function. So unit step function shifted to the right hand side by t, it is shifted to the left hand side by the t. So the unit step function means, actually you can say it is like a get function whose one side is unbounded. Means you have basically opened it. Both the sides were closed and now you opened it. So open in the sense, open, there is a limit, so limit become infinite. So it becomes a unit step function. So anyway, so now if you just do the convolution, what shape you can expect? The CT. Again, first you have to understand that from where it should start and up to which extent it would go.
So my limit on t-axis will be from minus t to plus infinity.
Minus t.
Yes, sir, because if we flip the ft,
Okay.
then we are going to get 0 at minus t.
No, that is not minus t. Whenever you, what I have told just a few minutes ago, when after flipping, if you find any overlapping portion, just after flipping, if you find any overlapping portion, that will correspond to C0. Means for that is the value of CT for t equals to 0. So just after flipping, whatever you are getting is basically corresponds to the origin, the value at the origin for this resultant signal. So here in this case, suppose if we just flip it, then at that point, what value you are getting? Means after multiplying, you have to find out the area. So are you getting any area?
Sir, it will be a linear
Sir,
increasing.
It will be a linear, very good. And
Yes,
a linear and
from
starts
origin.
from origin.
From origin,
Fine,
yes.
fine. 0 t. Because if you flip this one, if you flip it, so it will start, it will be like this. Okay, now just compare these two, this one and this red colored signal. So this point, at this point, there is, if you try to find out the area will be 0. Okay, so area will be 0. Now, if you further slide this at the left hand side, obviously at the left hand side there is no overlap. Now you have to slide it to the right hand side with respect to this. So as you are moving it to the right hand side, sliding it to the right hand side, gradually the area under the curve is going to increase. And how it will increase? It will increase linearly. So it will be simply a linear ramp function rather. Okay, and of course the slope will be 1. Sorry, I mean 45 degree actually. Okay, so anyway, 1 bolte pare asubidha nei. So 45 degree. Okay, so 45 degree angle. So it slope will be 1. So in this case, you just see we know that if from this example, a very interesting property regarding the convolution can come. And the property is something like that. Suppose you have one signal ft, and you have another signal, suppose if t minus tau, which is a shifted version of this signal, which is basically shifted version of this signal. Now what is going to happen if you suppose convolve between these two, if you convolve, then what is going to happen? That before shifting, whatever shape of the convolve signal you are expecting, that shape or that signal is going to shift by this amount. Suppose, for example, let's take an example. Suppose you have a unit step function and you are trying to convolve the unit step with itself. That means again the two signals are unit step, identical. They're starting from the zero, like this, unit step, this function. There is no shifting. Now, after doing this convolution, what you will find? You will find a ramp function. Obviously, it should start from zero. It cannot extend. Okay, so a ramp function starting from zero, extending up to infinity. Unbounded signal, ramp function. Now, suppose if I shift it one unit step, these two are identical signals. If I shift this by some amount, suppose tau at the right hand side, what is going to happen? This ramp function will also be shifted at the right hand side by the same amount, by tau. That means the resultant signal will be RT minus tau. As if before shifting whatever convolve version we have shifted that by the same amount, by which one of the signals shifted. And again, if you extend this property further, that means suppose one of the signals shifted by minus tau in the right hand side, another signal shifted by tau at the left hand side, that means plus tau. So what will be the resultant shape? First, for this minus tau, it will be try to shift to the right hand side by tau. For this, again, it will try to shift left hand side by the plus tau. So resultant thing will be so equally from both the sides. So actually it will not move anywhere. So kind of equal force are applied. Okay, in the concept of physics, you can say. So it will basically remain at the rest position. It will remain fixed at that position. So it will be rest at t equal for, or that means from start from t equals to 0. That is the thing happening here. So this we have shifted by t in the plus side. This we have shifted by minus t in the negative side. So resultant thing is that as if the thing is not getting moving, remain fixed to its previous position. That means if we do the convolution between unit, as I mentioned, unit step, where both the signals actually starts from 0 and extend up to plus infinity. If we do the convolution, we will get this signal, exactly ramp signal, this function. In this case, what we have done, we have shifted this to the right hand side. We have shifted this unit step to the left hand side, but by the same amount. So in doing it, as we have shifted in two different directions, but by the same amount, so that as if the resultant effect get cancelled. The resultant things get cancelled, and the net effect is that it remain unmoved. The convolved signal remain unmoved. So that is happening here. So it is basically unmoved. It starts from 0. As if it is a convolution between the two unit step functions. And this is the thing. But if I move only one out of two to any direction, then what is going to happen? The resultant signal will move, the convolved portion will move to that direction by that amount. This is the property. This is a very, very good property. It's a very powerful property of convolution. So that actually comes from this simple example. It can be proved mathematically also. Now, so we learned that if we do the convolution between two unit step function, ut convolved with ut or ut convolved with itself, then we get a ramp function, kind of ramp function. Then obviously t valid from 0 than equals to 0. So now the question is, if we do the same convolution between two unit step functions in the or for the discrete time case, then what we will get the output, or what would be the nature of the convolved signal? Will it be same as before? That means for the continuous time counterpart, or anything else? Unit step, the discrete time domain.
Sir, n of un.
N of un. N of un to basically ramp function, you know. If I write n of un, then what is the difference between these two? এই দুটোর মধ্যে কি তফাৎ? un বলাতে তোমার সুবিধা হলো যে এইটা লিখতে হচ্ছে না, এই তো অল্প, তাই তো?
Yes.
বেসিক্যালি দেখি মানে এখানে আমি যেটা লিখলাম, তাহলে আমি সেটাই তো আমি জিজ্ঞেস করলাম, তাহলে আমি বলতে পারি যে whether this convolved version is the same or analogous to this, or exactly identical to this.
Yes, sir, discrete time domain ওরকম ramp function টাইপের।
টাইপেরই কথাটা খুব ভেগ কথা। এক্স্যাক্টলি আমি এটা পাচ্ছি ইয়েস অর নো, ইয়েস অর নো।
Yes, sir.
ইয়েস, সেইটা
Yes, sir.
ইয়েস বলেছো। কে কে আছো যে নো বলছো? এন ইউএন আমি পাচ্ছ না, এটা তুমি না বলছো কারা কারা? কেউ কি আছো?
স্যার n+1 হবে না?
ভেরি গুড, n+1। কি করে বললে? কোত্থেকে বললে?
স্যার মনে মনে ফ্লিপ করে স্লাইড করে ভাবছিলাম।
করছিলে, বাহ, ভেরি গুড ভেরি গুড। এই তো এটা আমি দরকার। এটা যদি তুমি সত্যি মনে মনে বের করে করেছো হাগো, আমি ধরে নিচ্ছি তুমি যেটা বলছো, তাহলে থ্যাংক ইউ ভেরি মাচ। তো ইয়েস, ইট ইজ নট n, it is n+1, n+1. Now you have to do it by yourself as your friend has done. So you have to do it by yourself and have to satisfy yourself. So do it and satisfy yourself that it would not be n, it would be n+1. Why it is so? That means when n equals to 0, it is not 0. This is the difference between these two. This is also ramp. Yes, this is also ramp. এই জন্য তুমি যখন বললে র্যাম্পের মতো একটা কিছু, মতো তো ঠিক আছে, ওই জন্য মতো কথাটা খুব অস্পষ্ট কথা। মতোটা তো না, it is exactly this or that or anything else. So এটা হচ্ছে basically n+1 into even. This is not n into even like this. এইখানে তফাৎ between continuous time and discrete time. কেন বলো তো এই +1টা এক্সট্রা এলো? +1টা এক্সট্রা এলো কেন? যেটা তোমার বন্ধু বললো, ও মনে মনে ক্যালকুলেশন করতে গিয়ে এটা বুঝতে পেরেছে +1 হবে, n+1 হবে। সো বাকিরা কেন মনে হচ্ছে যে ও কি ঠিক বলেছে? বাকিদের কি মনে হচ্ছে, ও কি ঠিক বলেছে?
স্যার n equals to 0 তে তো কনভলিউট করলে 1ই আসবে ভ্যালুটা।
n equals to 0 তে কনভলিউট করলে 1ই আসবে। আচ্ছা, তাহলে n equals to
স্যার যেহেতু এটা ডিসক্রিট টাইমে রয়েছে, ওই জন্য আমি যখন u of n আর u of -n দুটোই দেখছি, দুটোর ক্ষেত্রেই তাহলে 0 তে 1 ভ্যালু থাকবে একটা।
ভেরি গুড।
তাহলে যখন কনভলিউট করবো 0 তে ওরা 1 ভ্যালুই দিয়ে দেবে। মানে আমি যখন কন্টিনিউয়াস টাইম ডোমেনে করছিলাম তখন ওভারল্যাপটা 0 ছিল, কিন্তু এইখানে 1টা ওভারল্যাপটা ধরতে হবে।
1টা ধরতে হবে কারণ ভ্যালুটা প্রিসাইজলি 1 ওখানে, তাই তো? 1
Yes,
1
sir.
তুমি গুণ করলে ওখানে 1 পাচ্ছ। ওকে, বেশ। আর কন্টিনিউয়াসলি যখন তুমি করছিলে তখন তুমি 1 আর 1 যদি ধরো, কিন্তু ধরলেও তো মানে অ্যাকচুয়ালি ওটা যদিও ডিসকন্টিনিউয়াস এনিওয়ে, বাট স্টিল যদি তুমি ধরো, তাহলে প্রবলেমটা হচ্ছে তুমি যখন এরিয়া আন্ডার দ্য কার্ভ করবে, এরিয়া আন্ডার দ্য কার্ভ করে তোমার উইথটা 0, এই জন্য ওটা 0 হয়ে যাবে। ঠিক আছে, ভেরি গুড, ঠিক বলেছো একদম। তো সেই জন্যই এটাই হচ্ছে তফাৎ, যে তোমার বন্ধু বললো যে এইখানে হবে 1 এবং তার রিজনটাও দিল, আর এখানে এটা 1 হবে না, এটা 0 তে 0, it is 0 তে at 0 it is 1. So that means when it is n equals to 1, it is 2. And here when it is t equals to, suppose for example 2, because ওই যে বললাম slope 1 45, so it will be 2. এইখানে একটা ডিফারেন্স কিন্তু থেকে গেল। দুটোই ড্যাম, দুটোই লিনিয়ার, একই, সবই ঠিকই আছে, কিন্তু স্টিল ওটা হচ্ছে অ্যাজ ইফ শিফট হয়ে গেছে কিছুটা, এই আর কি। এনিওয়ে ঠিক আছে, এটা মাথায় রাখবে, এটা খুব শর্ট কোশ্চেন আসে। আচ্ছা, এবারে আমরা একটা এক্সাম্পল দেখি। এবারে আমরা একটু ইয়ে করি, একটু গ্রাফিক্যাল মেথডের হেল্প নিই। সাপোজ এক্সাম্পলটা দেখ, this side, left hand side, the signal which is written or drawn is xt equals to e to the power 2t u of minus t. Please note, in examination sometimes it may happen that the graphical form will not be given, or the shape of the signal will not be given. So probably the mathematical form will be given. So from that mathematical form you have to first draw its graphical form. That means the graph or the nature of the signal you have to first draw, because if it is asked that you have to do it graphically, then you have to. And in doing so, obviously first the basic thing that are required, you have to draw the pictures or the waveforms of the two signals, individual two signals. So here it is, one is xt, if it is x to the power 2t u of minus 2, this expression is given. So based on that expression you have to first draw the picture. So suppose let's assume that everyone can draw it. So this is the picture, and again ht is u of t minus 3. Again it's a basically unit step function shifted to the positive axis by t amount or t second. Okay, t axis or t second, suppose, or t unit. So this is the shape of the signal, h of tau. So here all the variables t are replaced by tau for the both the cases. Now we are interested in doing the convolution. So in doing so, first what we have done, we have just here, what we did, we just flip the h of tau and make it h of minus tau. So flipped or fold or rotate, whatever you say, about the vertical axis, y axis. So you just flip it and it becomes h of minus tau. And here at h of minus tau is actually this point. This point now comes here at this side. Okay, you have to just keep a note on that. You have to carefully observe that where this point actually goes. Fine, because ultimately you have to, whenever you will slide it, whether at this direction or that direction, whenever you will slide it, you have to basically this is a kind of reference point, kind of reference point you have to track. Then the analysis will be easy. Now this example already we have done intuitively just a few minutes ago. So intuitively I have already done that. At one side you have a exponential, the one function is exponential decaying function, another function is basically a unit step or the flipped version of the unit step functions, like that. So we have already done. Now it is something like that. Now this is a unit step, exponential function, as if it is decaying in this side for the negative value of tau, decaying like this. And this is a flipped version of the unit step, because the unit step, if I follow this as a exponential decaying function, and the unit step is supposed to be at this direction, but that is flipped to this direction. So one is a flipped version of the unit step, and another is the exponential decaying function. So we have just now done the example, and there we know what will be the shape. It will be constant up to t equals to 0, and then again it starts decaying exponential, this kind of thing. And here also we are getting almost same kind of thing, but only thing is at this point, so this is basically the point of discontinuity. This point actually shifts. There in the previous example, the point was located at t equals to 0, I think. Here the point is shifted because of this shifting in the nature of one of the signals. You just see, this signal was kind of the same. It was e to the power minus t, and here it is just e to the power 2t of minus t. So it is kind of same, almost same. But this is a shifted version. This is a shifted version. So unit step function, it's a folded version of the unit step in that sense. If you consider this exponential as a analogous to our previous exponential, so in that respect, it is kind of flipped to this direction. Okay, in that respect. But again, this is not only flipped, this is also shifted by 3. And that is why that in our previous case, the shape of the signal was, the convolved signal was like this. So that point of discontinuity was located at the t equals to 0, but now it is shifted at t equals to 3 due to this shifting. You just see the the example. This example clearly tells you the property I mentioned just now. If one of the signal is shifted by some amount, the resultant signal will also be shifted by the same amount and the same direction. Now, anyway, so if you do the mathematics a bit, so the mathematics is very simple. Here with respect to this point, suppose when this point, this t minus 3, this is actually the t minus 3 point. So because at t equals to 3, it is 0. So at t minus 3 point, this t minus 3 point actually now comes ultimately to the minus 3. T minus 3 is now located at minus 3. So that is why it is written t minus 3 equals to minus 3. So t minus 3 equals to minus 3. So when this point, this t minus 3 point, this point is less than equals to 0, less than equals to 0, this point, that means actually, that means from here we can write that t is actually less than equals to 3. So when t is actually less than equals to 3, then what is going to happen? Now here in that case, actually my integration would start from minus infinity, and it actually extend up to this t minus 3 point. T minus 3 point. As long as this point, just follow this condition, this point is less than or equals to 0. Then it's okay, obviously, because if the signal is suppose here at this, take any arbitrary position like this. So here, that means what? That means it actually we have to start from the minus infinity and we will extend up to this point. That means this t minus 3 point. T minus 3 point. So, okay, fine. The limit is okay. And then you just multiply between these two and just do the integration. It's very simple. It is half e to the power 2t minus 3. That's all. But when this point actually crosses this, that is greater than 0. Actually, I think there 0 equals to 0 should not be in both the cases. In one case, you can take 0, and in another case, you just omit the equal to sign. So anyway, just to greater than, suppose 0. So if it is greater than 0, that implies that t greater than equals to 3. When the t greater than equals to 3 or t minus 3 greater than equals to 0, the same thing is 0, then obviously this is the signal that is actually going to dominate, or that is actually going to dictate rather, that what will be the shape of the convolved signal. Because whatever part of this signal is going beyond this range of vision or window, then I will hardly bother with this because there is no overlap between this signal and that signal for that part. That means for the positive value of tau. Okay. So in that case, we will discard. So basically the limit will be from minus infinity to 0. Similarly, so limit is set minus infinity to 0 e to the power this signal, and then if you integrate, it will be half. So here also, it is just look at here, it is actually half. So the shape of the signal is actually same what we got previously, but the absolute value may differ, the position may differ a bit, but again intuitively you can say that yes, the shape would be something like this. So this is another example, you can see. And we can take another example. Yes, this one. This is another example. Now, in this example, again, The mathematical form is given, as well as the pictorial or the waveform is also given. So the waveform of xt is basically 1 for small t, ranges between 0 to capital T, and otherwise it's 0. That means it's basically a gate function whose height is 1 and width is t, capital T. And this is actually nothing but ramp function, but the point is, as there is a limit, okay, at this side it is bounded, this side also it is bounded, so it will kind of behave like a triangular function. Okay, it will be kind of a triangular function. So as if I have three 1, 2 and 3 edges of this, so it's the kind of a triangle, so whose width is 2t and height is actually, again, it will be also 2t because the slope is 145 degree. So at 2t it will be 2t. So with this, if we again go for the convolution, what here we are doing, we are basically first keeping this fixed, we are flipping this. So whenever we are flipping this, so this function will go at this side. So this thing happens. So this point comes at minus 2t and the height remains same, 2t. Now you just shift it. Now in the process of shifting, basically three different ranges in general are taken. So this is a one general range. Whatever will fall between 0 to t, that's the one setup range, you can say. This is another setup range. This is another setup. So within these three sets of ranges, actually, all you can cover the full nature of the your exponent. The convolution signal or convolve signal. So here the range is between when the t is from 0 to capital T. Now, please remember one thing: the width of this signal is 2t and the width of this signal is t. So this is the minimum. This signal has a minimum width. Out of these two, this signal has a minimum width. So the tricks we did last class, from there we know that the minimum, the signal whose width is minimum, that is actually going to dictate the range, okay, or whose base is minimum, that is actually going to dictate the range up to which you get the maximum area or maximum overlapped area. That is actually going to dictate. So remember this thing. Now what is going to happen? Now let's see. So 0 to capital T, this point again. So this point, suppose it is t, and if it is t, definitely this point is t minus 2t. So this is t minus 2t. And now I am going to slide this point like this point. This is again, it's a reference, is a pivotal point kind of. If for the reference it is required, you just see how this point is moving along this axis. And take different ranges, like these three sets of ranges they have taken. So 0 to capital T. 0 to capital T means this is actually 2t. And 0 to capital T means actually within this range, 0 to t. Okay. So in this range, within this range, actually, if you multiply this just to see, because after all it's a 45 degree angle, so means this height and base is same. So naturally, this if you add, this is 1. So naturally, if you multiply at this position between these two signals, at the base you will get t, at the height you will get t. That means it will basically dictated by this point. If the t is at this point, then obviously you will get this triangle, this kind of triangle. If t is at this point, you will get this kind of triangle. So whatever the point of t may be, doesn't matter, as long as it is in between this 0 and capital T. So you are going to get a triangle whose two arms are equal. The base and the height are equal. What is exactly t? So obviously, and you know how to calculate the area under the curve. So it's basically half t square. So this is half t square from within this ring. Now next come, if t crosses, if this point actually crosses capital T, but it is within capital 2t. Capital T, but it's within capital 2t. Now, before doing the convolution also, you know that both the signals is a time limited signal, as a finite length, a finite base. So definitely the base for the one is 2t, the base for the other is t. So obviously the base of the convolved signal will be 2t plus t, that's 3t, and that we know. So we have to basically, that is the range will be from 0 to, obviously from 0 to 3t. Why it is 0? Because if you just after flipping, after flipping, whatever common region or portion you are getting, that is fine. But if you slide it to the left hand side a little bit, your common portion will vanish. You will not get any common portion or overlap portion. So that means that range will be from 0 to 3D, that you know. That can be known from other point also, other way also. That's one for the one, the lower limit is 0, this lower limit is 0. So if you add 0 plus 0, it will be 0, and the upper limit is 2t, 3t. So the range we know before doing the operation. Anyway, so but out of that total range of 0 to 3t, 1 up to 1, that is 0 to t, one part, that is we have divided into 3 parts: 0 to t, t to 2t, and then 2t to 3t. So within t, we know how it basically varies. It's varying basically half t square. It's basically varying parabolic way. Fine. Now that means from up to this region, you know, it is basically going to vary in a parabolic way. Though my picture is not very good looking in that sense, but anyway, it is actually, it will not be linear. It is like a parabolic nature. Anyway, so now t to 2t, then at this point, this t crosses this limit. Please note, this t actually crosses the width of this signal and it goes outside the window. And whenever the tailing part of the signal that goes outside t, we have to cancel, we have to discard. So naturally, the shape will be something like a triangle. At one end, it is okay, because ultimately you have to multiply this height by this height. So again, that will be always t. But what is going to happen, the tail part, this t up to t, if you just extrapolate this line following the same slope, so this will basically touch here. So in that case, this is supposed to be t, this is t. Okay, but whenever it crosses t, so this part goes beyond the range of the vision or the window. So you have to discard it. So that is why the shape would look like a trapezium. Okay, some part of the triangle, if you cut it, so then it will be just a trapezoidal shape. So it's like a trapezium. And obviously, you can divide it into 2 parts. One is the triangle part, the upper portion, and the lower portion is the rectangle. So in this way, they have calculated the area of this trapezium. Fine. So look at the nature. Here also, this part is constant. Please note, this is half t square is always getting subtracted from this. But here it is varying with respect, that means this convolved signal between this range is varying linearly with time. And all these are constants. All these are basically constant. You just look at this function very carefully. It's constant. So it will be basically linear. Though my picture is telling something, but that is not true. It's hand drawn, so it is not correct. So you have to draw it correctly. So here actually it will be non-linear. Here it will be linear. Okay, but again, subtraction, that is the part, but that is the constant part. You have been subtracting. That is different thing. But most of the nature is linear. It will be linear, and here it is non-linear. So because we are going to represent the signal range by range. So for one range, how it should behave. For other range, how it should behave, like that. So range by range. So in this way, it will be easier for you to visualize what actually happening. And also the analysis or kind of mathematical treatment will be easy. Again, the third range is of course 2t to 3t, because you know when this is 2t. So this is 2t, and when it crosses this last point, actually crosses this t, then obviously the total range will be just this point. Just to think when this point actually overlaps with this point. So then it will be total length will be t plus 2t, that means 3t. So 3t will be the maximum. If it goes beyond the 3t or crosses the 3t limit, then there will be no overlap, sure, 0. So we don't need to look beyond that. Now, what is happening between 2t to 3t? Again, from 2t to 3t, always remember, if this is t minus 2t. And I'm basically interested in 2t to 3t. Now, this point actually goes beyond, it is actually 2t, beyond 2t. Suppose this is t, this is 2t. So beyond 2t, it goes, and definitely this tail will enter within the right hand half of this axis or this quadrant fully. There will be no value like two previous cases at this quadrant, second quadrant. So everything, all parts of the signal will come to the first quadrant. That means all parts will be there for the positive value of tau. Unlike the two previous cases, where some parts of the signal were in the negative, for the negative value of tau, that means the second quadrant. Okay, so in that case, the full signal I am getting at the right hand side in the first quadrant. And anyway, so at this point, you have basically, again, if you just you see, if you multiply, so here you should be very careful, because as some part is actually what is happening, some part, if you just look the position of this signal with respect to this, some part there is no overlap, because this signal exists but this signal doesn't exist. And again, beyond t also this signal doesn't exist, even though this exists. So again, there will be no overlap. So the restriction is very within this t minus 2t. This point is now very important. T minus 2t point, this tail, and the t, the lower limit is set by this and the upper limit will be set by this. So within this range, the shape will be like this. So look at this, the same thing. This is the shape, and you have to find out the area of this. Again, the same trick. It will be easy if you divide it into triangle and rectangle. Then you do the calculation. The shape will be something like this. Now here you have two things. One is the non-linear part, and there's a linear part. Non-linear part is the negative sign associated. That means it is basically a curvature is in the opposite direction. But the linear part is a positive side. Anyway, so the dominating part is the non-linear part. So if you again plug in all the values, so that shape will look like this. And so the resultant shape would be something like linear, then non-linear, non-linear, then linear, then again non-linear, mostly. So this is the shape of your YT, which is the convolved version of this XT and HT. And this is a very, very interesting, very good example. Okay, so it's done graphically or pictorially. A little bit mathematics is also there. That is obvious. That should be always. So in finding the calculating the areas under the curve for three different conditions. This condition is very simple, but these and these two, for these cases you have to take the area of the trapeziums. So anyway, so with that you have to finally calculate, or rather find out the shape of the resultant convolved signal, the range, their shape, their nature, etc., whatever you say. So this is the thing, YT. Now the highest value this signal has or got, and that is at t, that when it will got, because when this, that will be dictated by this, which has a lower base or smaller base, lower limit, 0 to t. This limit is smaller with respect to this limit. This is 0 to 2t. Okay, so when it will be maximum, the maximum it will be at t equals to 2t. When t equals to 2t, suppose from here you can take t equals to 2t. Under that condition, what is going to happen here? Exactly at t equals to 2t, this point is at 2t here. And this point exactly coincide with this axis, 0 point. That means that this point will be at 0. T minus 2t point, exactly at 0. So under that condition, you are getting the maximum value of the overlap portion. But before that, some portion of this signal was falling outside the range of this. Again, after that, if you cross this point, crosses 2t, as I mentioned here, some portion, this tail is now actually crossing, going to the right hand direction, crossing this value. 0. Crossing this vertical axis, it is going to the right hand side. So definitely there will be some, non-overlapping portion. So again, the area will decrease. So area will be maximum when this point, or rather this point t minus 2t will coincide exactly, and that will be only when this t point will be exactly at equals to 2t, and that is happening here. That is the thing. So now in the homework I'm giving you, so based on this, if you understand this thing, it's very simple, nothing to worry about. Now with this understanding, you have to do two things in your home, and just take it as an assignment. So you have to do the graphically, you have to show the convolution between two signals, and out of which one is this one, exactly xt, which is shown over here, and the ht first case will range from 0 to t. Please note 0 to t, not 0 to 2t. That means in that case, in this example, in this problem, what I'm giving you, in this problem, the width or the base of these two signals are same. This is also from 0 to t, height is 1. This signal will be from 0 to t, and again, as it's a RAM, so obviously at t, the height will be t. So, got it? It's the first problem. You have to do it graphically, step by step. And take the second problem. The second problem also, again, this signal is same signal, 0 to t, 1. And this signal will be from 0 to 3t. 0 to 3t, not 2t. And again, the RAM function, range will be from 0 to 3t. That means at 3t, your height will be 3t. That's all. So this little, I have done a little bit variation in the range of this RAM function, and I have kept this thing same as it was. So with these two problems, you will understand how the nature with the variation, it's basically the impact of variation of the base of this RAM signal, how it is going to affect or influence the nature of your resultant signal or the convolved signal. That message you will get from these two examples, because already you have this. This is as a reference to you in this case, and with respect to that, you can compare when the width is smaller, how it should behave, or rather behaving, and when the width is larger, how it is behaving. So it's basically the impact of variation of the width of one of the signals on the overall nature of your convolved signal. You will get it from this two examples. One examples followed by these two problems I have given just now. Okay, got it?
Yes, sir.
Okay. এটা হোমওয়ার্ক হিসেবে করবে। আমি কিন্তু পরের দিন র্যান্ডামলি যে কোনো কাউকে জিজ্ঞেস করতে পারি, যে নাম ধরে, ধরো তুমি বলো কি করেছো, মানে so you will basically, after doing this, you will get almost 1 week time, enough, I think. So, and you have to do graphically. You have to do graphically. I'm telling again and again, graphically, like drawing pictures, and if required, to draw the overlap portions. Okay, you can shade also this overlap portion and so on. So you have to do it graphically. Now, I may randomly pick anyone from you, maybe 1, 2, 3, 4, based on my own decision at that time. So, and then I may ask you that you have to show the screen, or to share the screen with all of us. So the rest of the class will basically see what you have done. So that is why everyone will be prepared, should be prepared with your own solution. Okay, I don't know whom I'm going to ask for sharing his or her assignment. Everyone should be prepared like this.
স্যার কোয়েশ্চেনটা একবার রিপিট করুন এইচডব্লিউ তে।
কোশ্চেনটা হচ্ছে এইটা যেমন আছে xt যে প্যাটার্নটা দেখছো, যে নেচারটা দেখছো, এটা অ্যাজ ইট ইজ থাকবে। অ্যানাদার সিগন্যাল যেটা ht উইথটা একবার নাও, একটা প্রবলেমের জন্য নাও t 0 to t, নেচার ইজ সেম। ওকে, RAM function 0 to t, and the second case, in the second problem, it will be from 0 to 3t. Okay. In the first problem, the width is less than what is given over here, and the second problem, the width is more than what is given over here. And you just take and do convolution using this graphical method, and you just see or find out, and then again obviously check how the shape of this resultant signal is going to vary. That means it's the impact of width on the nature of the convolved signal. ঠিক আছে, বুঝতে পারলে?
Yes, sir.
Yes, sir.
So as I mentioned, everybody has to do it, and everybody will be prepared with their own solutions and a soft copy, because I will ask anyone, that may be anyone, single person, or maybe more than one, and that will be randomly, totally randomly, and then you have to share it. At that time, I will not want to get any kind of excuses from you. That's because of this I cannot do, or my internet connection is poor. Sir, I have done but cannot capture through the camera, or I cannot scan it. Sir, I don't know how to share it. These kind of lame excuses is not going to be entertained. You have to show it. Whenever I will ask anyone, I will call you by your name. That's you just share. You have to share. No excuse will be entertained. Just remember it. Okay. Next. Now we have done some examples related to the continuous time domain signals. Okay, as far as the convolution is concerned. Now, in the discrete time domain, or dealing with the digital signals or the discrete time signals, we have some advantages. As I mentioned in the last class also, that in the discrete time domain, there are several types of tricks. There are several types of mechanization method of mechanization or mechanical method with which we can do the convolution very easily, because this is due to the inherent nature of the discrete time signals, because they are ultimately some values. After all, there are some values, nothing else. Okay, but it is not totally applicable or 100% applicable in case of continuous time case. But you can do in a direct way, but again, not in a direct way. Suppose, for example, this case, you have basically this signal HN, and you have XN. XN is defined in the following manner. Just look at the manner how it is defined. 1 for n equals to -2, 0, and 1. 2, again, it's a mathematical representation. And actually, there is no need to draw the picture, because here we are not going for a rigorous method. Neither we are doing any mathematics, nor we are going to draw a graph. Okay, so just a mechanical way. I'm going kind of a table, with using a table in some certain manner. So it's basically mechanical way of doing or finding out the convolution. So what we are doing, suppose xn is represented in, the sequence representation. It's called the sequence representation. You know that. So in terms of the sequence representation, I'm going to represent xn. So just look at here, 1, 2, 1, 1 at 0. When n is 0, it is 1. When n is 0, it is 1. It is written. When it is 1, it is 1. And again, when it is -1, it is 2. And when it is -2, it is 1. And elsewhere it is 0. So that means elsewhere means for other values of negative and positive. So I don't need to bother, because ultimately there is no non-zero values there. So I don't need to consider. So just you just ignore it. So this signal xn is actually effectively a time limited signal, a finite length signal or sequence. So the length is of course 4, and hn is represented like this. Delta n minus 1 minus delta plus delta n minus 2 minus delta n minus 3. So that means what? Delta means actually 1. In discrete time domain, the definition is very simple. The concept is very simple. It is just one, precisely one. So value is one. So 1 minus 1, 1 minus 1. So look at it. And note another thing, that we have not used any arrow, upward arrow, to indicate that this is the pivot element, because I have already mentioned, if nothing is given or written or drawn, that is implied that the leftmost element is the pivot element. So that means this actually corresponds to n equals to 0. Now, and the starting value of your n, that means that starting value means actually the convolve signal here they want to mean. So the convolve signal, obviously, you know, if it is 4, so the range or the length of the convolve signal will be 4 plus 4 minus 1, that is 7. That we know already before doing the convolution. And if it is 7, it's okay. But what would be the starting value? From where it should start? There is no necessity that it should always start from 0, as I've already mentioned, because here some of the elements is there for the negative values of n. So here the point is, or the tricks is, so for how to find out the leftmost element for the convolve signal. The leftmost element, the position of the convolve signal, to find out, you have to basically add this n1 plus n2, n1 plus n2. So starting point will be, n1 means that starting point for this, which is nothing but your, this is 0th element, this is minus 1, this is minus 2, and this is 0. So the first one element is 0. So 0 plus minus 2 will be the minus 2. So the minus 2 position will be the starting point for the convolve signal. And also it will extend, because we know the length will be 7. So obviously it will extend up to minus 2 plus 7, that is plus 5. So it will extend 0, 1, 2, 3, sorry, that is 0. So it will be extend up to 4. 0, 1, 2, 3, 4. So it would extend up to 4, because we have to consider the 0 as well. So 4, up to 4, that we know. So minus 2 up to 4, because in between there is a 0. So we have to consider that. So total will be 7. Anyway, so what we actually do in this method? We don't need to bother anything about the mathematical formula and all those stuffs and graphical, their shape, how they are varying, etc., etc. We don't need to bother. Okay, so here we are basically first, it's like a matrix kind of, you know, how we represent the matrix or do kind of calculate, kind of. So here, or sometimes people call it an array representation also. So here, xn, we have just below xn, this is xn, this corresponds to xn. So we have just written their values as it is, 1, 2, 1, 1, just as it is, without doing any flipping or this kind of thing. Here also, hn, as far as the hn is concerned, the other side, other arm is basically two-dimensional. Okay. So again, we have just written the values as it is, 1 minus 1, 1 minus. Look at this, 1 minus 1, 1 minus, as it is. No flipping, no changing, nothing. Okay. Now, what we're doing, we're just multiplying this by all other elements of this xn. Suppose take the one value of hn, that is 1. You just multiply all 1, 2, 1, 1. Again, with minus 1, do the same thing. Minus 1, 2, minus 1, minus 2, 1, minus 1, minus 1, 1, minus 1, minus 1, like this. So in this way, basically, I will get 1, 2, 3, 4, 4 rows, and obviously 4 columns. So it's a 4 by 4 matrix kind of. But here, after doing that, we have to add, because this is the multiplication part. The addition part is still there. So you have to add. Add will be the diagonal addition. So additions are diagonal. For that, these lines are drawn so that you can understand how we are supposed to add. So this is the first element. There is no other element. So obviously the first value will be 1. In case of this, within this, whatever the number of elements will be there, will be added. So whatever elements will be there, minus 1 plus 2, again it will be added, give you plus 1. Yes, plus 1. So this is the second element, plus 1. Then you add these 3. In the diagonal position, these 3 elements are there, 1, minus 2, 1. So if you add, it will give you 0. So the third element will be 0. In this way, you just add all the values you will get as given here, yn. So here, as I mentioned, so just you can follow this method, that first to find out what are the leftmost element. Okay, leftmost element, that is here, it is that position, minus 2, here it is 0. So you add, then you find the leftmost position. This way you can find, and then you know the total length. From that you can find this limit, etc. Also, there is another technique that without going to calculate, you don't need to calculate it. Just to do here, you just locate what is the pivot element. This one is a pivot element. In this case, you just locate what is the pivot element. This is the pivot element. So this element, this one and this one is going to interact at this point. Look at that point. This is the pivot element for Xn. This is the pivot element for Hn. So two pivot elements are interacting and producing the result here. So you just follow this track where these two pivot elements interacting and giving some result. You just follow that diagonal, the other elements located to that diagonal position, and you just add on. So you just add on, this means this 1 plus 1 minus 2. So this result will correspond to the 0th position of the Yn. So if you know what is the 0th position, the rest of the positions are known to you. So again, this is another method. Basically same, different way to look into it. Anyway, so this way we got the Y, the resultant signal, that's the convolved signal or sequence, and we know the limit, the pivot element, position of the pivot element, the value of the pivot element, and all those stuffs. So this is the one way, very simple way you can do it, and it is another example. It is shown that again Hn is 1, 1, 1. Okay, here it is Xn is 1, 2, 3, 1, 2, 3, 1. Length is 4, length is 3. So definitely the length of the convolved signal will be 4 plus 3 minus 1. That will be 6, and that is written over here. That length will be 6. And again here no arrow is given. That means this is the pivot for this. This is the pivot element for this. So again, two pivot elements. They are the first elements. There is no element for the negative value of n. So if you just do the calculation, the first element for Yn is supposed to be from 0 equals to 0. N equals to 0, sorry. From n equals to 0. We'll start from n equals to 0, and that is actually happened here. So if you just do the same thing, you just write Xn, just put the values, Hn, put the values as it is. Again, you just multiply and then add diagonally. You are going to get this pattern. 1, 3, 6, 6, 4, 1. The total length is 1, 2, 3, 4, 5, 6, 6. We know that beforehand, before doing it. And obviously, this is the pivot element. There is no need to show the arrow because by default, the leftmost thing will be the pivot element. So we got it. Now, the beauty of this method is that just without understanding anything regarding convolution, it's a very basically mechanical way. Without understanding anything regarding the convolution, the shape of the signal, any mathematical formula, okay, how this is varying, how the signal one is getting slided with respect to other, how the overlap area is going to change. Okay, this kind of complicated stuff you don't need to bother about. It's a very tabular method, kind of mechanically, just an array you just declare and you find out to the calculation. And so it will basically save your time and energy, and of course, you will come up with the appropriate value, right value. Okay, so this is possible in the discrete time case, but the continuous time case, this is not possible exactly in this manner. But yes, it is possible to implement because you know the way it is implemented. You know the continuous time things are implemented through any digital system. The way it is possible, because for implementing this, you have to again discretize all those things, and again you just do the calculation in this domain, and again you have to convert everything to the continuous time. In this way it is possible. So you can take the help of this kind of mechanical method. It will be easy because in this way you can save or store the data in the memory, and you can do the processing. Suppose the one algorithm, you just write out a program and you can run this. So you can very easily find out convolution between any two signals. It is possible. So in this way, these kind of methods are very helpful sometimes. Okay. So if you have a knowledge, you can apply this anywhere. Okay. And if nothing is mentioned, you can also apply this method in the examination. If nothing is specifically mentioned. Otherwise, you can follow any method. Whatever methods you know, you can follow. Okay. Now, and that the main thing you have to notice that even though we are doing the convolution, still in this method, in this mechanization method, we have not actually flipped any one of the signals. We have not flipped it. The signals values are written as it is. No flip operation is there. That means in this algorithm, actually algorithm is such that, or the method is such that we are basically coming out with the appropriate or proper values of the sequences, convolved sequences. But for that, there is no need to flip it, flip any of the signals. You have to remember this in this algorithm. Again, because you have to, if you have to apply, whenever you will write the program, if you flip, because at the back of the mind, you know that you have to flip one. If you flip, then the result will be wrong. Just remember this thing. And this is another method, but again, that is not so popular, but again, you can do it also. Here, it is a pure tabular method, you can say. Here, for maintaining kind of a database kind of thing. So here you have the xn and the hn. Again, the pivot element is this, and here in this case no arrow, so the pivot element will be this. And again, before doing the operation, we can calculate 4 plus 4, 8 minus 1, so 7 will be the length of the convolved signal. And in this case, what we are doing, we are with k. So we have written k. So k actually varying from -4 to +7. Here it is written. And where actually first we should mention this thing, that x of k, you have x of k, and x of k, for x of k is written here 3 2 1 2, x of k, x, and this is the values of k. So k means at k equals to 0 we have 3, at k equals to 0 we have 3, at 1 it is 2. In this way we have written the x of k. And here this is for n equals to -1 0 1 2 3 4 5 different values. Actually we have another signal h of n. That signal we are going to write like this. It is basically you are tabulating the convolution in its exact form. You understand from here like that. Suppose for n equals to 0, n equals to 0, what is that? H of 0 minus k, so that means minus k. So basically you have flipped it. Look at this. At 0th position, it will be 0. Sorry, 2. It's okay. But the left hand side actually comes to the right hand side. And the right hand side actually goes to the left hand side. So it is actually a flipping operation you have done over here. And this is a shifted version of the left hand side. This flipped signal, this flip pattern, suppose you have shifted to the left hand side by one sample. And in this way, you have shifted to the right hand side by so many samples, unless and until this whole pattern actually goes outside the range of this signal xk, either at this side or at that side. So the last I will get is for at this side, left hand side, for -1, n equals to -1, and the last one I will get at the right hand side is for n equals to it is I think 6 though, but a +5. Okay, 5. This thing. So in this way, what we are doing now, for each and every step, for each and every shifting, so as we do, you know that we have to first multiply. Here you are, after multiplying, there is no other multiply term with which you are can add. So obviously it will be 3 exactly. But here, suppose in this step, you have this 3 into 2 plus another term that is getting multiplied, that is 1 into 2. So these two terms after multiplication will be added. Look at this, it is added. Similarly, here the 3 terms after multiplication with their respective xk values will be added. So in this way, I will get this pattern, this sequence, which is the convolved version between these two. So the difference between these two is that here exactly it's a replica of what mathematically or graphically we do. It is just a way to represent a database kind of. So the data is there, and you are representing it the same way, following the same algorithm that is applicable for the convolution operation. Here you have to flip the way you are storing. It is obviously following the protocol because you have actually flipped it, all of the signals, shifted it like this. All the steps or sub steps are actually properly maintained through this your database or architecture. You have maintained that, but here it is not like that. Here it is not like that. It's complete mechanization method. And this is very faster. There are lots of things you have to remember. You have to carefully, again, you have to note how it is getting shifted and which direction, and all the steps you have to always carry in your mind. Even though whenever you are writing a program or for that maintaining this data, you have to carry that thing, extra burden. But here you don't need to bother about anything, any such complications. So overburden is more for this, but not for this. So that is why this method is not so popular, but this is very popular. Okay. আচ্ছা, এবারে আর দুটো প্রবলেম একটু তোমাদের দিই কনভলিউশন রিলেটেড, তোমরা এটা বাড়িতে করবে, এগেইন হোমওয়ার্ক। তো হোমওয়ার্কের একটা সেট অফ প্রবলেম হলো, আর একটা সেট অফ প্রবলেম দিচ্ছি, ওটা ওই লাস্টে যেটা দিলাম ওটা কন্টিনিউয়াস টাইম ডোমেনে ছিল, এখানে ধরলাম ডিসক্রিট টাইম ডোমেনে দিচ্ছি। ঠিক আছে, এটা ডিসক্রিট টাইম ডোমেনে দুটো প্রবলেম ধরো এরকম করতে পারো। সাপোজ মনে করো you have two sequences, one is the hn which is suppose কি বলবো a to the power n un for all values of n, and we have suppose xn which is b to the power n un for all values of n. Now here you have to do the convolution between these two. I have not given a numerical value, okay, just based on a and b you just do depending on a. No value of, so specifically I have not mentioned any values for a and b, okay, just whatever the your expression will come, that will be in terms of the a and b. Anyway, so here you have to do it under two conditions. When the first condition is when your a is not equals to b, and the second condition is when a equals to b. For these two conditions you have to find out the the convolution between these two signals, okay. And the second problem you can take, the second problem, suppose you have yn. This problem you can do by your own, but by your own means obviously by your own you have to do this, applying any method whatever you want to, okay, you have to do it, you can do it rather. And this, for this second problem you have to apply or adopt the method called graphical method. So with the help of graphical method you have to do the second problem. It is specific, I have specified that actually. Yn equals to yn, you have to find out what the value of yn, obviously, which is, or better to say yn xn, again hn, xn hn, where xn is suppose n plus 2 for n less than equals to 0, less than equals to 3. This is for xn. And hn suppose a to the power n un for all values of n. So this is the xn. Xn is n plus 2, where n ranges from 0 to 3, and hn is a to the power n un, where means for all values of n, this form. So again you do this convolution by applying graphical method or graphical technique, but here you can apply any method of your own, any method, whatever you want to you can apply. So again you have to do this to this set of problems. This is from discrete time, okay, discrete time domain related convolution problem, and the previous one was from the continuous time. So you just do these two, and these two are the homeworks for your next class. So you should be ready with these two. Follow. আমি জানি সেই জন্য আমি তো এটা করেই কমপ্লিট করে দিচ্ছি, ঠিক আছে? তো এই দুটো একটু তোমরা করবে পরের দিন, এবং যেভাবে বললাম you should be ready with this solution. I can randomly pick anyone or other more than one from you, and then you have to show it instantly. So you should be well equipped with everything so that whenever I ask you to show, you can show. ঠিক আছে? Any question regarding this?
No, sir.
No, thank you. ঠিক আছে। আচ্ছা আচ্ছা, একটুখানি তোমরা কানেক্টেড থাকো, আমি তোমাদের অ্যাটেন্ডেন্সটা একটু নিই। Roll 3 years আর কি, 3 years বিটে roll 301 absent, 302 possibly absent, 303
303
present, 306
প্রেজেন্ট স্যার
306 okay,
প্রেজেন্ট স্যার
হ্যাঁ ঠিক আছে, 307 to absent, 308
Present, sir.
present, 9
308.
Present, sir.
হ্যাঁ 308 প্রেজেন্ট দিয়েছি, 309 ও প্রেজেন্ট আছো, ওকে। 310
present sir
11
yes sir
আচ্ছা 311 হলো, তারপরে কত আছো? 312 নেই, 313 315 absent, 316 318 absent, 319 320 321
present sir
322
Present, sir.
23 323 absent, 24 absent, 25
Present, sir.
3 ইয়ার্স এর কেউ কি বাদ গেলে? সবারটা হয়েছে?
3 to 5 দিয়েছেন?
3 to 5 হ্যাঁ প্রেজেন্ট, হ্যাঁ 3 to 5 প্রেজেন্ট, ওকে। তাহলে আমি এবার 4 ইয়ার্সে গেলাম। 4 ইয়ার্সের 401
Present, sir.
406
প্রেজেন্ট স্যার
8
Present, sir.
11
Present, sir.
16 316 absent,
Sir, present.
present
Present.
আচ্ছা দাঁড়াও, আচ্ছা তারপরে আজ কত আছে? 318
Present, sir.
319 319
Present ছিল ডিসকানেক্ট হয়ে গেছে।
আচ্ছা ঠিক আছে, আমি করে দিলাম। 32 সরি 3 বলছি, আই এম সরি, 419 420 420
Present, sir. Present, sir.
ওকে ওকে 425
Present, sir.
427
Present, sir.
8
present sir
9
Present, sir.
30
প্রেজেন্ট স্যার
1 31
Present, sir.
2 432 absent, 433
Present, sir.
433 sorry 433 প্রেজেন্ট, তাই তো? আচ্ছা 435 absent, 36 absent. 37 437 absent. 438 okay ঠিক আছে কারো বাদ পড়েনি তো 4 ইয়ার্সে ওকে ঠিক আছে তাহলে আমাদের নেক্সট ক্লাসটা আবার তাহলে সামনের বৃহস্পতিবার ওকে ঠিক আছে থ্যাংক ইউ
বুধবার।
স্যার বুধবার
সরি বুধবার হ্যাঁ বুধবার
হ্যাঁ স্যার।
হ্যাঁ ঠিক আছে